Good morning, my fellows and friends. My name is Edward Wasroom. I will be looking at the nonlinear ARDL models this morning. Actually, we'll be looking at how to estimate nonlinear ARDL model. I will actually look at how to interpret nonlinear ARDL model. Then, in subsequent videos, I will also look at how to generate the long-run symmetry and the short-run symmetry using the wild text of coefficient dynamics. I also need to actually show you how to plot the graph of the nonlinear ARDL model. So let's start. The nonlinear ARDL model is an extension of the ARDL model that was put in place by Pesaran et al. In 2021. Nonlinear ARDL model was established in 2014 by Pesaran et al. The essence or the significance of nonlinear ARDL model is to actually decompose the independent variables into its components, into its negative and its positive components, to actually unravel if the negative impact or negative component of the independent variable will affect the dependent variable negatively or positively, or if the positive component of the independent variable will affect the dependent variable positively or negatively. Basically, the nonlinear ARDL model enables researchers to actually know if the drift in the independent variable have a homogeneous impact on the dependent variable. So this morning we are actually adopting a study approach wherein we are going to be actually looking at how remittance affects poverty in Nigeria for the period spanning 1981 to 2020. The data sourced from the World Development Indicators and the Central Bank of Nigeria is handy and useful this morning. So to begin, the nonlinear ARDL model maintains all assumptions of the linear ARDL model, but the difference in the nonlinear ARDL model is that the independent variable is being decomposed into its negative and positive form. So to start with, we assume that the basic condition for estimating nonlinear ARDL model is upheld, meaning that we have a mixture of variables that became stationary after phase difference, a mixture of variables that became stationary at level. Also know that the lag length for this estimation is actually known. So to start with, you go to quick. From quick, you go to estimate equation. You now estimate the normal linear symmetric ARDL model, which is the normal ARDL model that I actually presented last week. EXR. We actually look at how remittance affect poverty, considering the exchange rate is a factor that determines the value of the remittance in a country, because if the exchange rate is high, then the remittance will be low. Whatever you are sending will be low, considering the fact that the exchange rate is taking a larger chunk of the money. So if you come to the method, you click under least square, you select the last in the option list. What I'm using is if it's 9 without changing any other thing, you click OK. I don't want to change the lag. Let me allow the lag. Let me assume that the lag is 4. The sample size remains 1981 to 2020. I click OK. I allow to delete other items that were needed. You will be exposed to this. Is the static ARDL model, ARDL 100. ARDL 100. The lag for this study is very low, but though for practical purpose, I will allow it. The number of regressors are 4 lakhs. Automatic selection. Estimated this day time. Poverty is the dependent variable. This is the ARDL model, but you can also check the long run results. From this result, you go to view. From the results, you go to coefficient diagnostics. You maneuver to long run form. You get your long run results, and you also get your short run and your long run ARDL output. So for we to do the nonlinear ARDL model, we need to go to view. You maneuver to label. You come over to this area. The nonlinear ARDL model is not in eView in default, but actually for you to get the nonlinear ARDL model, you need to go to add-in, download it as an add-in or addition to what you have already. Once you download it, then you can be able to use it. So once you are able to come to this page, you click here, type in ASIVAS, asymmetric variables, ASIVAS. You type in ASIVAS, Then this other side, you type in the variables. You actually starting with the dependent variable and the independent variables you are actually working on. You click outside the box, then you go to this add-in to identify the nonlinear ARDL model. You click make nonlinear, then you'll be exposed to this. This is your nonlinear ARDL model estimated this day, the 25th day of July 2023, time 6:15 a.m. You look at this is the nonlinear ARDL model. This is the the static nonlinear ARDL model. This is the static nonlinear ARDL. We have the poverty lag 1 to lag 3. We have remittance, positive remittance. We have negative remittance. Positive remittance has lag 1 to lag 4. We also have exchange rate has lag 1 to lag 4. If I actually want to reduce the lag length of this study, I can also come back to estimate. I can go back to estimate to select lag 2. If I pick lag 2 for this study, then the lags will be reduced to enable me know what to do when I want to do the long run restriction. This is how it will appear. If you want to go to the long run form, this is how the result will appear. So going back to lag 4 as actually we've done before, this is the previous result we actually had. So it can reduce this result to a number that can be parsimonious for you if you actually wished. So let me proceed to the long run form. The long run form of this result, you go to view, you go to coefficient diagnostics, you maneuver to long run, integrating a long run form. You'll be exposed to this. I'm not comfortable with these results because the ECN value is not positive, it is not negative, and is not significant. So this result is not parsimonious for me. I'll proceed to estimate, to adjust this result. So to do that, I go to estimate. I proceed to see how I can reduce the lag to enable me get actually what I wanted. I maneuver back to the coefficient diagnostics to check if I have something parsimonious. Something parsimonious as 10%, but actually needed something parsimonious at 5%. For practical purposes, I will leave it at this. If you are doing a study that needs to be published, ensure that your ECM value is negative and less than 1, and that your ECM value is actually less than 5%. So what we are having here is 7% and is not attainable, but for practical purposes, I will leave it at this while we proceed. So I haven't gotten this. The next thing to do is to actually interpret this result. This is our short run ARDL output. This is our long run ARDL output. But after interpreting this result, you have to actually derive the long run asymmetry of this result using the vertex. I believe in my next video, stay tuned to this video. In my next video, I'm going to teach you how to derive or how to identify short run asymmetry in ARDL models, and also how to identify long run asymmetry in ARDL model using the vertex framework. Stay tuned as I get back. Thank you.